Hello everyone, welcome. Welcome to the Study Hacks Institute of GIS and Remote Sensing. So basically today is our fifth number test for complete online training on Google Earth Engine for remote sensing and GIS analysis. So basically today's session we discuss about that air quality monitoring, all parameters. So any kinds of parameters such as nitrogen dioxide, sulfur dioxide, methane, aerosol, how we can easily monitor, as well as how to download the air quality parameters time series data in CSV file format. We also discuss about that, and also discuss about that air quality monitoring time series chart, how we can easily create the temporal chart of air quality monitoring. Also discuss, and how to calculate the total emission of any specific gases for nitrogen dioxide, sulfur dioxide, or methane. We also discuss about that, and we also discuss about that AOD, basically aerosol optical depth, and also talk about the particulate matter 2.5, how we can easily monitor, as well as we also discuss about that after downloading this type of data, how we can easily make the map using ArcMap or QGIS software, and also discuss about the accuracy assessment of your air quality parameter map. We also discuss, and how to extract the points pixel value for a specific geolocation, because it also help you to monitor the accuracy assessment. We also discuss about that, and how to check the trend of your any specific gases, what's the trend. We also discuss, and also apply the linear regression model. Okay, so one by one I will try to discuss all of topic, then I hope you can easily get the idea how to use remote sensing to monitor the air quality parameters. So first of all, air quality monitoring using remote sensing is a powerful tool, and we can easily assessing atmospheric pollutants over the large area using this remote sensing tool. It complements traditional ground-based measurement by providing special continuous data, open and global and regional scale. And we are just use the remote sensing without going to the field, without physical contact. We can easily access the air quality parameters. Okay, so now we talk about that some key satellite and sensor for air quality monitoring. So first of all, if you check some satellite for air quality monitoring, so here you have the different types of satellite for air quality monitoring. So first one is that we can say that it's very popular. It's called the Sentinel 5P mission or 5P satellite. We are just used to monitor for different types of air quality parameters such as nitrogen dioxide, sulfur dioxide, methane, aerosol, or carbon monoxide. Not only for that, we also use another one. It's called the NASA URA. So this satellite imagery is also monitoring the ozone monitoring instrument. It's called the OMI, and we can easily monitor the nitrogen dioxide, sulfur dioxide, then ozone or aerosol, as well as we can also use the another satellite. It's called the Terra and Aqua. Terra and Aqua for MODIS. We can monitor Terra and Aqua. So it's a we can easily monitor using the Terra and Aqua MODIS, aerosol optical depth, or smoke or dust. So these type of things we can easily monitor, as well as we can also use the another satellite. It's called the GOM2. Okay, so this is the abort mid op. We can easily monitor different types of gases using this satellite, nitrogen dioxide, carbon monoxide, or sulfur dioxide, as well as we also use the another one. It's called the GOSAT. So basically this type of satellite we are used to identify different types of air quality parameters. So Sentinel 5P, then NASA URA, Terra and Aqua for MODIS, then GOM2 and GOSAT. So this type of data we can easily download from different sources, as well as some data set also available in the Google Earth Engine data catalog. So then we can easily use this type of data and monitor the air quality parameters. And we can easily detecting nitrogen dioxide, sulfur dioxide, carbon monoxide, methane, ozone, and PM 2.5 and PM 10. It's not available directly, but indirectly we can use the AOD, basically aerosol optical depth, and further we can also measurement the PM 2.5 or PM 10. Okay, so I'll try to show you that all of process how we can easily use this type of satellite, and then how we can easily monitor the air quality parameters. So first of all, we try to use the Sentinel 5P. So this dataset is available in the Google Earth Engine data catalog. Simply browse data catalog, and here we find out all of dataset. Click on Sentinel, and here we can easily find out Sentinel 5P data. Propomy, if you check, this is our dataset. Sentinel 5P tropospheric instrument. So from here we can easily access all of gases such as ozone, then methane, then formaldehyde, then aerosol, then carbon monoxide, then nitrogen dioxide, sulfur dioxide. We can easily access all of gases. So if you check, we find out this type of gases. We can easily use this type of data and monitor the air quality parameters. So suppose I will show you the one example. Suppose I want to use the carbon monoxide. This data I want to use, and further I try to show you the example. So just click, then you can easily find out this type of data set. So it's called the offline, and this data set can be two types. If you check, all of data sets are the two types. One is the offline, another is the near real time. Okay, near real time data is more update. Okay, this data set is more update data, and offline it's not more update, but we can find out the data more better. So I want to use the offline, but when you monitor the near real time, then try to use here the near real time data. Click on the carbon monoxide. So here you can see this data set availability time. We find out the data between this time, and its provider European Union, yes, Copernicus, and this is the Earth Engine snippet. Okay, this is the Earth Engine snippet, and if you check, we find out that this is the pixel size, and also find out that your band name. So this is the band. If you check, this band basically carbon monoxide column number density, a mole per meter square unit. Okay, and if you check, we find out that another one, it is the water vapor column. So water column number density, water vapor, as well as we can get the scatter layer height, so sensor altitude, so different types of layer. So this type of layer we also use for the different types of analysis. But in this case, I want to monitor the carbon monoxide column number density. So that's why I want to use it. So let's go ahead, just simply import this image collection, just copy and open on your, just paste on your code editor. Okay, just paste. So just I paste in my code editor. So here I just give a variable name. You can put any name as a variable. You can put any name. So I put the name, suppose I put the name is dataset. You can put any name as a variable. So now I simply import my image collection. So this is the Sentinel 5P satellite. We are just import the Sentinel 5P, your carbon monoxide offline dataset. We simply import it. So as well as if you want, you can also download this type of data. So further I'll also show you that how we can easily access this type of data, and also work the NASA URA dataset, then Aqua, then GOM, then GOSAT. So this type of satellite, how we can easily use, I will try to show you that. So now from this dataset, I simply choose a band. Okay, suppose which band I want to work. So now I want to work this band. Okay, carbon monoxide column number density. This band I want to use. Just I copy the band name and paste on the code editor. So now further, just simply give a time period. Just to create the filter date function and put your specific time period when you monitor the carbon monoxide. So just I simply put the time period, suppose year of 2025, suppose January. So I take the data for year of 2025, suppose January 31. I take the 1 month data, but if you want, you can put any specific time period, any season or any summer season, rainy season, or any month or any year, you can simply put the data. So now it's very easy. So I simply call the Sentinel 5P satellite data. So just simply import the Sentinel 5P ozone. Basically it's a carbon monoxide data. Carbon monoxide data. I simply import it and also select for a specific band, which band I want to work. So I simply select and also put the time period. Okay. So now further we simply check how many images are available in my dataset for this time. Just print and call the dataset and use here the size function. Okay. So size function basically it's computing how many images are available in a collection. So we find out that 426 images are available in a collection. Okay. So now further, if you want, you can simply make a chart. Suppose I want to check for a specific coordinate. What's the temporal chart of carbon monoxide, when it will be high, when it will be low. So I want to monitor this type of things. So for that, if you want, you can simply import your shapefile, or you can take a marker. Suppose this is my study area. So for this study area, I want to make the time series chart. So just I simply take a geometry. If you want, you can also change it. I put the name suppose as a ROI. So now for this ROI, I want to check the temporal chart. Okay, so using this dataset 426 dataset, I want to check it. So now it's very easy. You already know about the function. This function called you can simply search here for function, make the time series chart. Simply ui dot chart dot image. So then we can easily find out all of time series chart, and from here I just use a chart. So this function is simply import. So first of all, you can see what is the first argument. So first argument is image collection. Basically, how many images you want to use. Okay, so in this case, I want to use the 426 images in month of January 2025. We find out. So this is my image collection. Okay, so this image collection is stored in a variable. This variable name is dataset. Just copy the dataset and paste here. Okay, then put the region. I put the name as the RY because I want to work with this study area. And reducer, I want to apply. Suppose I want to calculate the average reducer. So reducer dot mean, compute the average density. And scale is the resolution of your satellite imagery. So I put here 1113.2 meter. Okay. And X property we are just use here the default system time start. So put here the system time start. So now the full things stored in a variable. So you can put any name as a variable. I put the name suppose chart, and further just print the chart. So print this chart, and now run the code. So now it's generating the time series chart, and if you check, we find out this type of time series chart. Okay, so we find out that if you check, we find out the highest value in the January 26. 0.064. Okay, highest density of carbon monoxide we find out. So this unit show as a mole per meter square. It show the result is the mole per meter square. If you check the satellite information, it show the mole per meter square. But if you want, you can also convert the unit. Suppose micromole per meter square. Okay, so now I will try to show you that how we can easily convert the unit. So it show the result as a mole per meter square. So how I can convert the unit in micromole? So it's very easy. So for that, just let me show you that how to convert mole per meter square to micromole per meter square. Okay, so now just simply convert these things. Then further we also make the chart for micromole. So how I can convert the mole to micromole? So if you simply search on the Google, suppose mole to micromole, then we can easily get this type of equation. If you check, this is the formula. So multiply the amount of substance value by this value or also this value. So when you multiply this value with the mole result, then you can easily find out the result in micromole unit. So now in this case, if you check, I want to multiply. Okay, this value I want to multiply. So how I can multiply this value. So if you want, you can simply put here the dot multiply and apply this value and run the code. If you check what happened, it show a problem. Okay, because this multiply, this function is only work for image data type. Okay, this multiply function is only work for image data type, but in this case this multiply function I just apply for image collection data set. This is the image collection. If you check the data type, so for that simply print, just print, and then call the data set, then put the function type of and call this data set, then we can easily find out the data type information. Okay, so just check the data type information. So we find out it's an object. Okay, so and it's a image collection object. Okay, not the image. So that's why when I compute multiply this value, then it's not work. Okay, it show a problem because this data set is a image collection. Okay, so now I want to create a function. This function help me to multiply this value. Okay, this value all of images. Okay, so now it's an image collection, that's why it's not work. So let's go try to create a function, and this function help you to compute the result. Okay, so let's go try to create a function. So for that, create a variable name. Suppose I put the variable name is that micromole. Okay, and then create the function keyword and put the element name, suppose img, and now just put your argument. So what is my argument? My argument is I want to multiply this value with all of images, total 426 images. I want to multiply this value. So for that, I simply take a element img, and this element I want to return. So just put here the return and multiply with this value, because I want to convert into mole to micromole. So when you convert to mole to micromole, then this value you need to multiply. So just I simply multiply. So now I take an element, and this element I simply multiply. Just I simply multiply, and further in this case I just use only for the one element, but I have also rest of other images. So for that, just copy these properties, use as the copy properties, and call the element and apply system type start to system time int. Okay, so just I create a function. Okay, so now this function simply connect with your image collection. So this is my image collection, and this is my function. So now how I can connect? So for connecting, just call this function, just call the collection. This is my total image collection, 426 image collection. I simply call and then connect with my function using the map function. So now it's successfully connecting and multiply all of images with this value. So now it's converted into micromole. So now if you want, you can make the chart. Suppose I just copy the same line of code, just copy and then paste here and call this micromole, because this variable stored all of images multiply with this value. So it's helped me to convert the micromole unit. So just I paste here. So now let's check the chart. So now it's create the another chart. If you check, so you find out this type of chart, and now the chart is show the result in micromole unit. So we find out this type of chart for the micromole. Okay, how much gas is density? We find out the density result is micromole unit. Okay, so this is the result we find out in here, and this is the result for mole, and this is the result for micromole. So now we'll show you that how we can easily make the trend analysis. Suppose in this case, for this time, what's the trend of carbon monoxide? It's day by day increasing or it's day by day decreasing? So let's go and try to explain about that, how to check the trend analysis. And if you want, you can also add the chart title, chart X level, Y level title. So for that, just use some option. Suppose just put here the dot set options, and apply the title. So I put the title, suppose carbon monoxide time series chart. Okay, you can put any title. Then put here the suppose y label, so v axis. So I put the title. It show the result for your, it show the result mole per meter square. Okay. Then suppose x level, horizontal axis, so x axis at the title. So I put the title, suppose it show the time or date. You can put anything. And now if I run the code, we find out this type of things also added. But in this case, you can see we find out this type of problem. So it not showing the continuous chart. Okay, it show this type of chart, dotted chart. We find out the dotted chart. So how I can create the continuous chart? So not only for that, when you face this type of problem, anytime when you face this type of problem to get this type of chart, after adding the chart title and y label, x label title, then we face this type of problem. Then you can simply add a function, add another argument. It's called the interpolate nulls. So this function simply use and open, just use the proof function and run the code. So now this function help you to create the continuous chart again. So now we find out this type of chart. If you check, we find out this type of chart and it display the x level time and also show about that y level and also show about the legend about that. So now this chart I want to use and make the trend. How I can check the trend? I want to add the trend line. So it show the increasing or decreasing, so we can easily get the idea from the trend line. So let's go try to add a trend line. So for that, just simply add a trend line and just apply the trend lines. And just it's only for the one line. So one line we define as a 0. 0 basically first item. So I put it the 0 because it's only for the one line. And put the trend. So just put here the type of trend. So I want to apply suppose linear trend. As well as if you want, you can also use the different types of trend. So I want to apply the linear. So now if I run the code, then you can check the as a linear trend line. You find out, you can see it show this type of trend line, linear trend line. So we find out that it increasing day by day. We find out this type of chart. It display the result, it increasing. Okay, so as well as if you want, you can also add the other style. Suppose I want to add the color. So I put the color, suppose red color or any color, you can simply choose and run the code. So now it show about that. If you check, we find out this type of red color. So this red color indicating about that increasing the trend of carbon monoxide for my study area. It means that day by day it increasing, day by day it increasing the amount of carbon monoxide for my study area. So we can easily add this type of trend line and then we can easily check the data, what the scenario, it increasing or decreasing for a specific study area. So we find out this type of trend for my study area. It show the result, it increasing the carbon monoxide for my study area. We find out. Okay, so further if you want, you can also add the other property. Suppose I want to add here another property to display the chart more better. If you want, you can simply use here that line width. Suppose I put the line width is suppose 7 pixel. Okay, then if you want, you can also put at the opacity. So I put the opacity suppose 0.2. Okay, and also add the legend. So for that, put at the visible in legend. Just open it, put here the 2 and run the code. So now it's added this type of information. We say add. If you check, we are just add the legend, okay, of trend line, as well as you also add the chart, this type of chart. So now this is a trend line. Okay, so from this trend line we can easily get the idea. Day by day it increased the carbon monoxide for my study area. So now if you want, you can also apply this type of things for any specific boundary. So for that, you can simply import your boundary shape file in the asset tab. So previous class I already discussed about that, how we can easily import the boundary shape file. So just from here, just I simply import a study area. Suppose I simply import that country boundary, or if you want, you can also use at this website, suppose US website. This is the another data set. It provide you the international country boundary polygon. So from the polygon, I simply filter my study area, okay, or a specific country. So take a variable, suppose RY, or I put suppose AOY, and then I simply call the table. This table I want to filter. So how I can filter? Art engine dot filter dot equal. So what's equal what? Okay. So now I simply put here what's equal what. So I want to filter using the country name and put the country name. Suppose I want to check the result for Bangladesh. Okay, just put here the Bangladesh. So now this AOI, it stored the international country boundary of polygon in Bangladesh. So now I want to display the carbon monoxide density map for the Bangladesh region of Bangladesh. So how I can display the map? So let's go try to display the map. So for that, take a variable. Suppose I put the variable name is the CO map, and then call our dataset. So we already have a dataset for this is our dataset. So this dataset I need to reduce. Okay, just I simply put the reduce, apply here that reduce, and apply EE dot reducer dot mean, and further just clip with our study area, which is AOI. So now we display the result. So just add here map dot add layer and call the object CO map and run the code. So now we display the map, and we can easily get the idea where is the high density, where is the low density, this type of things we can easily get it from here. So it look like this type of color, but if you want, you can also add here the color map. So for that, there already provides some demo color code. So just I copy from here this color code and paste on our code editor. Just paste. Okay, so after that, just I check the stressing value. I kept suppose the stressing level as 98%. So it gives me the mean and max range. Just copy, put the minimum range, and also copy the maximum range, and further just copy this variable name and add after the object name, and I put the layer name, suppose CO map or carbon monoxide map 2025. So just run the code. So now this it's also added the color, and we can easily get the idea where is the high density. So if you check this type of color, it's indicating the high density of carbon monoxide. Okay, we find out this type of color, and this type of black color or dark color, it's the low density. This type of place we find out, but this type of place we find out that high density of carbon monoxide. So if you want, you can also check the value. So for that, just click on the inspector tab and suppose click on here. So we find out that if you check the value for this chord, we find out that 0.054 mole per meter square. For this coordinate, we find out the 0.054 mole per meter square density of carbon monoxide. Okay, or if you check this type of place, so it's a show the low density of carbon monoxide. We find the 0.03, this type of place. We find out the 0.043, okay, for this coordinate. So this is the way to compute the time series chart, as well as also compute the trend line. So from the trend line, we can easily get the idea where it's increasing day by day or decreasing day by day. So this type of information you can easily get, and from this map we can easily get that where is the high density of carbon monoxide, where is the low density of carbon monoxide. You can easily get this type of idea. So not only for that, any data set if you want to check using this way, further you also need to check the accuracy of your map. So for the accuracy, we need to download some ground truth data. So then we try to apply the root mean square error, as well as we can also apply the R square or correlation. So from this correlation or root mean square error, we can easily check the accuracy. Okay. So this is the way to compute the this type of things. And suppose I want to apply the another data set, I will show you that how we can easily apply. So what I am to apply for nitrogen dioxide. So it's very easy. Same process, simply apply. So simply copy the snippet ID, and further just I change it. So just I simply change my previous image collection. Okay, just simply change it. And now simply change the band name. So in this case, I want to use the nitrogen column number density. So this is the nitrogen column number density. It's same unit, mole per meter square. So I just keep the same, simply change it, and I want to monitor it for month of January 2025. So now if I run the code, you can check what happened. Just run the code. So now you can get the result for nitrogen dioxide. If you check, we find out this type of chart. But in this case, if you check one problem, if you check this problem, this is the nitrogen dioxide chart, but in this time it show value 0. If you check, it also show the 0. Okay, so it show the 0. So it's a common problem because in this time we find out the very less concentration or less density of nitrogen dioxide. So that's why it show this type of value 0. So when you face this type of problem, any data set, then you try to change the unit. Okay, so suppose in this time it show the unit for mole per meter square, but when you just convert the unit, suppose micromole, when you convert the unit in micromole, then it will be okay. So for how I can convert the micromole unit, we already discussed about that, how we can easily convert. So for that, you need to multiply this value. So this is the value. This value, when you multiply with mole result, then we can get the result in micromole unit. Okay. So in this case, we find out this type of problem. It show null value. But if you check the another chart, which I already create in here, in this time you can see it show the value. We find out because it's a micromole unit. You can see find out the value. So we find out that micromole unit 497.021 micromole per meter square density of nitrogen dioxide in the January 12, 2025. So it's very effective. So when you face the problem, it show the 0. 0 means that it's null value, but it also have a value, but it is very less. Then you try to just simply convert the unit mole to micromole. Mole to, when you convert the mole to micromole, then we can easily get this type of value. Okay, further we download the data as a CSV file, also download the photo as a PNG file format. So now if you want to check, we find out this type of map. If you want, you can also add here the better color combination. So for that, just simply click on here and stress it again. So now it give you the maximum and minimum range. So I simply change it because it's a previous for carbon monoxide. So I simply change it for new visualization of nitrogen dioxide. So just I paste here. And further I'll change it. It's a NO2, nitrogen dioxide. Just run the code. So now it display the map for nitrogen dioxide concentration. You find out this type of map. So basically, if you check this red color indicating about that high density of nitrogen dioxide, this type of red color, and this type of black color or dark color, it show the low density of nitrogen dioxide. And this is the result only for month of January 2025. Okay, so this type of place, it's very low concentration, but this type of place we find out very high concentration. Okay, in the Dhaka city or urban area, we find out the high concentration of the nitrogen dioxide due to the different types of anthropogenic activities. And this type of place, it show the low. Okay, if you want, you can also check the value. Suppose just click on here and check the value. So now we can easily find out for this coordinate, what is the value, 0.0025. okay, mole per meter square. So this is the way to make the different types of map using Google Earth Engine, help of Sentinel-5P data. Okay, but not only for the Sentinel-5P, we are also using the different types of satellite to monitor the air quality parameters, such as if you check NASA, Aerosol imagery, Terra and Aqua, then go to GoSat. Okay, this type of data you also try. So I simply search, suppose I simply search here GoSat data, or simply search on the Google. So if you check this website, so this is the another data source. We can also download the GoSat data from here. Okay, so if you check, basically it's monitoring different types of ozone gases. We can also monitor. And we can also get different types of global gas concentration animation also showing here. So if you want, you can simply choose your gases. You can see, you can also monitor the carbon monoxide and also monitor the methane. Okay, so from here you can simply choose anyone. Suppose I need the methane, and then you can see the version. So this is the update version, so I want to use it. Then year, so you can see different types of year. So it's available from 2009 2021 or entire I just put, and you can see the time step, so daily or 6 hour, so I put the daily. Then you can see the projection, so different types of projection, so I want to use it. And also you can see the center location, you can also put here that. And also particle level, so you can see different types of particle level. I put the column average and then click on the view. So now it just show you this type of animation, or you can put the different types of range of time or date. It also show the different types of animation you can find out. So we find out this type of animation, okay, from 2009 to, because you can also change the time period also, suppose for a specific month or a specific year. So then it also display this type of data or animation you can also generate from here. So you can also download this type of animation also from here. I suppose I want to check for carbon dioxide. I need the data for, suppose, check for year of 2022 daily. Okay, then view. So now you find out this type of animation. So it show the raise data for year of 2022 daily concentration of carbon dioxide animation. We find out that, okay, and also added the legend. So from the legend you also get the idea where is the high, where is the low. So it is globally available, this type of data. And you can also download this type of data from here. Just click on the download, so then it will be downloaded, this type of animation. Okay, you can see the 6 hourly data and daily. So these two types step we find out to create the global gas concentration animation for nitrogen dioxide or methane. Okay, from the GoSat we can easily check from here. Or you can see the different types of vertical level you can also apply. And central location, you can just try about 120 and view. So then we find out this type of things, but this better. This central location is more better for this projection. So now it's look more perfect. So then further you can simply download this type of data from here. So this is the GoSat data archive. We can also download for yearly or monthly or daily. This type of thing we can download from here. As well as you can simply search here, suppose NASA URA. Then this is the another data source. So from here you can also get the data for different types of air quality parameters. So this is another satellite data we also use for monitoring the different types of air quality parameters. Just click on the data source, then you can easily find out. So you can see the data processing and also URA science publication. So different types of publication, external data sources. So you also check suppose this type of data. You can see the suppose nitrogen dioxide. Click on here. So then you can easily get that. Just a minute. Okay, I think it's a privately accessed. So let me check for sulfur dioxide. Okay, so you can find out this type of, you can see near real-time images we also generate from the sulfur dioxide. You can also download the data. You can also select your study area. You can see the you simply choose your study area. Further, you can simply download the data from here also. So you can see, you can simply choose your study area, and further you can also download the data. Suppose I just put in here the Central Asia, and you can check the month. So which month you want to need the data. Suppose I put here that I need the data for April, and also choose the time. You can see this data set basically available from 2004 to 2025. Okay, 2004 to 2025, any year you can simply choose. Suppose I choose the data 2024 and then submit. So now it generates the data for Central Asia, but sometime it show a problem. I think it's not available for the globally. So let me check another. Yeah, so now I can check it, show the data. Okay, we find out this type of data. So August 5, then August 6. Okay, so you can see the previous month or next month. Okay, so it show the August, and you can also get the different types. You can also time series plot you can also create from here. So you can get this type of time series plot, and also click on here. So then we find out the NPP image. Suppose tropomy image, just click on here. So now it show the tropomy images. Okay, you can see, you find out this type of images. Just click on here, then it look more perfect. So you can see this type of result. And from here, this is the sulfur dioxide. So you can easily download this type of data. Okay, and this is the data time. Okay, you can see, so different types of images we also get from here. So this is the another one. We also try to use the NASA Earth satellite imagery to monitor the air quality parameters. And also, so you can see it also show this type of source type: oil and gas, power plant, then smelter, then volcano. So then click on here, then you can easily get this type of result. So this is the result for August 1, 2, 3, 4, 5, 6. We can easily get, and you can choose just click on here, it show the trophy image now. Okay, and just click on this map, then it will be look more perfect. Just click on here, then you can easily get this type of imagery. And this is the reason about that, and it show the sulfur dioxide. Okay, this type of color indicating about the high, this type of indicating about the low. So further you can simply download this type of imagery. So this is the way. As well as if you check the GOM2, so this is the another. So this is the global ozone monitoring experiment 2. So you can also get the download the data also from here for that. Click on the download data. So you can see download this type of data from this link. They are also provide. Just click on here. Yeah. So now you can also download the data from here, from the GOM2. So for that, you can simply click on here. You can see, so different types of parent identifier you can also use in here, as well as you can see the free text or title, others, and different types of filtering process we can also get from here. You can see different types of platform. So I put the world view 3. So you can see the instrument. I put it. And let's put the time period. Then simply search. In this time there is no. Okay, let me try for 2023. Okay. So these things you can also download the data and also visualize different types of air quality parameters data from the GOM2 and also download from here. Okay, again another download. So now we talk about that GoSet data. We already discussed about that. So GoSet data, if you want, you can simply search here, click on here. Okay, so now we talk about that how we can easily apply the MODIS, Aqua and Terra MODIS for monitoring the aerosol optical depth or dust. So click on the modis, and here you can easily find out the modis AOD data. If you check, so this is the modis Tran Aqua land aerosol optical depth daily data. Click on here. So now we find out this is the modis aerosol optical depth. So we can easily use this data and we can easily monitor the dust, as well as this data is also help you to convert the aerosol optical depth to particulate matter 2.5. If simply search here, suppose AOD to PM 2.5, so you can easily find out this type of statistical approach, how we can easily converting the AOD into PM 2.5. So in this case, we simply apply the statistical approach, and further we can simply monitor. Okay, so you can see when you converting AOD aerosol optical depth to PM 2.5, we need this type of data. Okay, first of all, you need the PM 2.5 mass concentration from the ground monitors. Okay, so this one is must you need from the ground PM 2.5. Some sample data you need to collect from the ground, as then you need to satellite data, you need to download the AOD. Okay, so you can easily get the satellite data AOD from this data set. It's provide the AOD, and then if you want, you can also add some meteorological field data, but it's optional. But we need this ground truth PM 2.5, as well as also need the satellite drift aerosol optical depth data, must unit. So ground truth data you can easily collect from the ground, as well as some administrative website is also provide for local region, so you can also collect from here. And satellite drive data or aerosol optical depth data we can easily get from this data set. Okay, for globally it's available. So after getting this data, we need to make the correlation. Okay, we need to check the correlation, or we need to apply the R square value. Okay, we need to apply the R square value. Then we need to create the linear equation. Linear equation basically y equal to mx plus c. So y basically PM 2.5 equal mx. M basically slope value, and x basically your AOD value, plus c basically intercept value. So this is the equation, and for this equation it find out the R square value 0.5. Okay, so if the positive value it show the strong correlation, negative value no correlation or negative correlation, and zero value it's indicating about the neutral. So in this time, first of all, you need to check the R square value and then create the linear equation. So then further we simply use the equation and compute the aerosol optical depth to particulate matter 2.5. Simply compute using this way. So let's go try to apply this data for AOD. So first of all, simply copy this data set and then paste on the code editor, and then give a variable name. Suppose I put the name is modis AOD. Okay, so this data set have a band, so this band you can simply call from your data set. So I want to apply the 0.47 micrometer optical depth. Just take copy and then use a function dot select and select this function optical depth 2.5 and put the time period. Suppose I put filter put here filter date function and put the time, suppose year of 2025 1st January, from I take the 1 month era 2025 01/31. I take the month of January. Okay, so now I want to create, suppose dot mean, I create the average and then just clip with my study area. Suppose my study area is, for this study area I simply import, suppose this is my study area, put the ROI, put here ROI. Okay. So now I want to display this map, so just use add a layer. So map dot add layer and call the modis AOD. Just I copy and paste here and run the code. And before that, I want to focus on my given study area. Map.center object. Object is ry and run the code. So now I directly focus on my given study area, and it's create the AOD, aerosol optical depth map. So it show this type of map without color. So I want to add some color. So just I copy and paste the color code. Copy this parameter, just I copy and paste after the object and on the code. So now this color is set, and we can easily identify for where is the high concentration of the aerosol optical depth. We can easily get the idea from here. So we find out this type of map. Okay, basically this type of place we find out the high concentration of the dust. Okay, and this is the result only for the 1 month. Okay, for the January. Okay, so if you want, you can also put here the suppose January to just put the summer season and check the result now in the summer season, January to May. It's loading because now it takes a lot of data within this time. It's loading. I think some networking issue, that's why it takes some time for loading. So after loading, you can simply get that where is the high concentration of the dust. We can easily get, and it's very helpful to identify for dust storm. Okay, So in the Middle East, we find out the dust storm. So we can easily identify where is the high dust storm. We can easily get the idea from this type of data. So if you want to check this type of application, just I simply show you that. Suppose just to open a new code editor, I simply search here dust storm. So I already write the code. So let me find out the code. Okay, just run the code. So now I can easily identify for dust storm area from AOD, aerosol optical depth. We can easily take the dust storm. In this time. Okay, so we find out this type of place, it dust storm region, and it generated from AOD data. Aerosol optical tape, we simply generate. So now you find out this type of place, we have find out the dust storm. Okay, and this data we simply generate from Modis AOD. Okay, from this Modis AOD. We find out the high storm or high dust for this type of place. So this is the one application to identify Modis storm, and further we also discuss about the TM 2.5. Before we discuss about the some practical example how to use Python and monitor the air quality monitoring. So further simply open the Google Colab. So in the Google Colab, we need to simply connect with our Google Earth Engine account. Okay. Okay, so I want to discuss about that. Suppose time series. time series analysis of suppose NO2. So how I can create this type of things, I discuss about that. So for that, just take the new cell and import some library. So we need to import one library, it's called the art engine, and also need to import another library, it's called the date time. Need to import another library, it's called the pandas. To create the data frame, we also use it. Okay, pandas as PD. Also need to import the matplotlib as a pyplot. So import matplot library dot pyplot, and also import GE map library. So just I simply import all of necessary library and run. So we find out this type of result, there is no error. And now simply initialize and also authenticate. So ee dot authenticate, just run. It's simply connecting with your Gmail. Okay, and then I want to put here the ee dot initialize and put the project. Okay, it's done. So further, I simply take a variable AOI and store it my region of interest. So I want to add a latitude, longitude, and latitude value. So put here ee dot geometry dot point. Okay, so and I put here that latitude and longitude as a list. So I put here latitude suppose 90.4125. This is my longitude, and latitude put here suppose 23.8103. So I put this type of latitude and longitude. If you want, you can also add the buffer. So basically it's a point, so I want to create a buffer study area. So then apply here the dot buffer and put the buffer, suppose I put the 30,000 meter. Okay, that put at the 30,000 meter. I put the buffer study area. Okay, so I simply put this coordinate, latitude, longitude, and latitude, and after that I put here the 30,000 meter buffer, and now put the time period, suppose date range. So just take a variable, suppose start, and put the date range. So put here ee dot date, and put the time period, suppose start time period, I put here year of 2024, suppose 1st January, and also put the in ee dot date, put the in time period, suppose year of 2024 or December 31. Okay, just I put this type of time period. So now after setting the time period, simply import the data set. Okay, so I take a variable, suppose collection. Suppose I want to work for nitrogen dioxide, so simply call the nitrogen dioxide data. I want to use offline data, so for that simply click on Sentinel again, and apply the Sentinel 5P Propomy. And I want to apply for Sentinel 5, I want to apply nitrogen dioxide offline data. Just copy the collection and paste here. After that, apply here the select function and put the band name, nitrogen columnar density, and also put the start and in, and filter bounds without study area. So now we face this type of problem, and now run the code. It's okay, there is no problem. And now I want to check, call the collection and check how many images are available. So just run the code. So now it's computing. We find out the total 5,150 images. So this is my total image collection. So I want to use it. So now I want to compute daily average nitrogen dioxide for each day. For each day, we try to compute, suppose daily. So this is my total image collection, but all of images have not data. Some images have a null value. Okay, because in this case I want to create the daily data. Suppose in the 1st January, I have total 10 data. Okay, in the 1st January I have to have total 10 data, but all of data is not valid. Some data is totally null. There is no value. We find out only for the one value for one date. So for that, I want to create a function. This function extract the daily average nitrogen dioxide. Okay, so we create a function. Okay, this function to extract daily mean NO2. Okay, extract the daily mean NO2. So just we create a function. So just take a variable, suppose def, and I put the function variable name, suppose extract mean. Okay, and now I put my element, suppose img, and put my argument. So what is my argument? So my argument is that I want to extract the date from my each images and also calculate the average for each images. So this is my argument. So for that, I take a variable date, and I call my element name and extract the date. So put here the date function, and also apply the format, date format. So for the format, I define the format, suppose year, then month and date. Just I define this format, and also compute the average. Okay, compute the average, daily average NO2. Okay, just I use it. So I call the element name and put the reduced region. I apply the reducer.mean to compute the average for daily, and geometry, it's my shapefile AOI. Scale is the resolution basically 1113.2 meter, and its get from this is the column name. Okay, nitrogen column number, density, and what I return from here. So what I return, so I want to return the data. Okay, and CSV file, it's called as a featured data, null featured data. It's called the null featured data. So for that, use here the return. I want to return ee.feature, but this feature there is no geometry. So for that, use here the none, because there is no geometry. For that, just put the none. And then what I return from here, I need the property date. I create a function, keyword and key value, date, and also put here the date. Okay, this is my column name I mentioned in here. And another is that it's called the NO2. This is my another column name, and it stored the average mean. Okay, basically this mean, it is stored in here. So this is my function. This function help me to extract the image date, every single images, and also extract the average value for every single images. So just I run the code. So it's create the function. So this function further I need to connect with my collection. So I have a collection. This is my collection. So I need to connect. So how I can connect? Just take a variable, suppose features, and I call my collection, and I connect using the map function. Put here the map function.